All right, here's your final exam review. The first one we're going to use substitution. U equals ln x, du equals 1 over x dx. So this becomes the integral from 1 to e of u du. So you get u squared over 2, 1 to e. But remember, these are x values. So we'll switch back to x. So we have ln of x squared over 2 from 1 to e. So we have ln of e squared over 2 minus ln of 1 squared over 2. Ln of e is 1. Squared is a half. Ln of 1 is 0 over 2. So we get a half. Right here we're going to use another u substitution. We're going to say u equals arc sine of x. Du is 1 over square root of 1 minus x squared dx. And so again you get u du. So you get u squared over 2. U was arc sine, so arc sine x squared over 2 plus c. Here we're going to use completing the square. So we got x squared minus 4x plus 7. So we have x squared minus 4x plus negative 2 squared. If I add negative 2 squared, I should subtract negative 2 squared. And so I get x minus 2 all squared. 7 minus 4 gives me 3. And so now I have the integral of 1 over x minus 2 squared plus 3 dx. So u is going to be x minus 2. A is going to be the square root of 3. And so this becomes, du is dx. So this becomes du over u squared plus a squared. That's an arctan integral. So I get 1 over a arctan u over a plus c. Well, a was root 3, so 1 over root 3 arctan x minus 2 over root 3 plus c. This one's all about the cosine being to the odd power. So I'm going to write this as cosine squared theta sine to the 8th theta cosine theta d theta. Then I'm going to take cosine squared and write it as 1 minus sine squared. Sine to the 8th theta cosine theta d theta. This distributes in here. Sine to the 8th theta minus sine to the 10th theta times cosine theta d theta. U equals sine theta, du equals cosine theta d theta. So this becomes u to the 8th minus u to the 10th du. So you get u to the 9th over 9 minus u to the 11th over 11 plus c. So you have sine to the 9th theta over 9 plus sine to the 11th theta over 11 plus c. Here we're going to use u substitution. We're going to use integration by parts. I'm going to say u equals x squared. Derivative again would be 2x. Derivative again would be 2. Final derivative would be 0. E to the negative 2x is going to be my dv. So the integral would be e to the negative 12x over negative 12. The next derivative would be e to the negative 12x over positive 144. The next one is going to be e to the negative 12x over 144 times negative 12. So match these up. I got plus minus plus. So I end up with x squared e to the negative 12x over negative 12 minus 2x e to the negative 12x over 144 minus 2 e to the negative 12x over 144 times negative 12 plus c. And then you would simplify this 2 in this denominator, this 2 in this denominator, and you would get your final answer after you do that simplifying. So here we're going to use trig substitution. Square root of u squared minus a squared equals a tan theta. So this means the square root of x squared minus 1 equals 1 tan theta. That only happens because u, which is x, equals secant theta. And therefore dx equals secant theta tan theta. Oh, secant theta tan theta d theta. So this integral becomes secant theta tan theta d theta over secant theta times tan theta cubed. Cubed because this is to the 3/2 power, so the square root is tan, and then you still have the third power. So we cancel out of this, and we end up with d theta over tan squared, which is the same thing as cotan, which is the same thing as, what's that going to be? That's going to be cosecant squared theta minus 1 d theta. And so the integral of cosecant squared is minus cotan, and the integral of 1 is theta. Switch back to your original variable, and so you end up with negative 1 over the square root of x squared minus 1 for cotan based off of this. And here we're going to get theta to be arcsecant of x plus c. And again, that comes from here. Okay, here we're going to do partial fraction decomposition. So the idea is we have this 4x plus 4 over x minus 5 times x plus 3 equals a over x minus 5 plus b over x minus 3. And so 4x plus 4 equals a times x minus 3, or x plus 3, sorry, plus b times x minus 5. And so we let a equal, or let x equal negative 3 and 5. If x is equal to negative 3, we end up getting negative 12 plus 4 over here, so we end up with negative 8. This one is gone because it's 0, and b times negative 8 is there, so b is 1. Now if we let x equal 5, we get 24 equals a times 8. Divide by 8, you get a equals 3. So this integral becomes 3 over x minus 1 plus 1 over x plus 3, x minus 5, sorry, dx. So 3 ln of x minus 5 plus ln of x plus 3 gives you ln of x minus 5 cubed times x plus 3 plus c. I'm sorry, but that's as far as I can go with this right now. I really don't have time to finish this up. I try my best to get this done for you guys. This is the best I can do.